close to the Earth. Scientists from the HESS Observatory in Namibia reported detection of electrons and their anti-material counterparts positrons, which they hit the Earth's atmosphere with the energy of more than 40 tera-electron volts. These are the most energetic particles of cosmic rays that ever it was detected. Researchers indicate that their source is probably relatively close to the Earth. Space is not fully understood by us processes and objects. We know that supernovae residues, pulsars, or active cores of galaxies are able to emit charged particles and gamma rays with the incredibly high energies, so high that they exceed energy produced by nuclear fusion in stars by several rows of magnitude. In recently published in the journal Physical Review Letters studies, astrophysicists from the HESS consortium reported the detection electrons and space radiation positrons with record high energy more than 40 tera-electron volts. These rays lose energy when traveling through space, which means their source must be close to Earth, of course, given the size of the cosmos. Gamma rays reaching our planet can do much tell them about their origins because they move through space without any interference. However, for charged particles, known as cosmic rays, things are more complicated. The space radiation travels through space continues to influence magnetic fields, and such fields are everywhere in the universe. This makes space rays reach the Earth from all directions. These charged particles lose some of their energy along the way, when they interact with light and magnetic fields. These losses are especially significant in the case of the most energetic electrons and positrons, of which the energy exceeds 1 tera-electron volt, TeV. Therefore, it is not possible to determine the point of origin of cosmic radiation, the authors of the publication indicate, although the detection of charged particles on Earth is a clear indicator that there are powerful accelerators of cosmic radiation particles nearby. Electron and positron detection with energies of several tera-electron volts are not easy to do. Space observatories have small cosmic radiation detectors that do not exceed the subway square and are unable to capture enough such particles. The instruments on the surface of the planet are larger, but they can only indirectly detect cosmic rays through the rain of particles secondary resulting from cosmic radiation interactions with Earth the atmosphere. The observatory located in Namibia HESS, High Energy Stereoscopic System, uses its telescopes to capture and recording of weak Cherenkov radiation produced by strong charged particles and photons that enter the Earth's atmosphere. Although the main purpose is to detect gamma rays to study their sources, data may also use to search for radiation electrons in space. Scientists searched a huge set of data collected within a period decades for 4 12-meter telescopes of the HESS. In their own the analyses used the most efficient algorithms that are able to extract the electrons of cosmic radiation from background noise with unprecedented performance. Thanks to this, they obtained a unique set of data for electron analysis, the cosmic radiation. From this set, they managed to extract data about space radiation with the highest energy ranges up to 40 TeV. This enabled them to identify refraction in electron energy distribution, the cosmic radiation. This is an important result, because we can conclude that the measured electron of cosmic rays most likely come from few sources near our solar system, far away to a few thousandths of light years, which is a very short distance compared to the size of our galaxy, explains Catherine Egberts of the University of Warsaw Potex, one of the authors of the study. Giant galaxy collision in Stephan Quintet. Astronomers have observed a galaxy collision in Quintet Stephana, a nearby group of galaxies consisting of 5 objects. One of the galaxies, known as NGC 7318b, hit the remaining at stunning speed 3.2 million km per hour. The collision was observed in unparalleled details by one of the most powerful telescopes on the Earth. Stephan's Quintet is located in the constellation Pegasus. How to it indicates the name. It is a group of 5 galaxies, although interconnectedness gravitational refers to 4, NGC 7317, NGC 7318a, NGC 7318b, and NGC 7319. Visually, the galaxy NGC 7320 is also included in the quintet, although it is 40 million light-years away, while the others are the components of quintet lie about 290 million light-years away. Quintet was discovered in 1877 by Edward Stephan. Researchers believe 4 interconnected galaxies in the distant future they will create one supergalactic. Recent observations using the most modern spectrograph that was mounted on William Herschel telescope and together form the William Herschel telescope and Enhanced Area Velocity Explorer, WEAV, has shown that NGC 7318b at 3.2 million miles per hour are ramping the other galaxies. Description of the observation and results of the research of the Pentateuch Stephan showed the monthly notices of the Royal Astronomical Society. The collision was spotted by a team of over 60 astronomers William Herschel telescope in the Canary Islands. They used a modern spectrograph mounted on a telescope 2 years ago wide angle, worth €20 million. This new generation device provides a new look at millions of galaxies across the universe. Stephan's Quintet, as scientists point out, is ideal a laboratory for understanding the chaotic and violent relationships between galaxies, therefore, was the subject of the first observations using WEAV. The authors of the publication compared Stephan's Quintet to a difficult one, galactic intersection, where there have been collisions before. There's the remains in the form of the remains are still visible. This cosmic debris is back re-excited through the passage of the galaxy NGC 7318b. Since the discovery in 1877, Stephan's Quintet enchanted astronomers because it is galactic a crossroads where galaxy collisions left afield the remains. Activity in this group of galaxies has now been reawakened by a galaxy that breaks through a group at an incredible velocity of 3.2 million km per hour, said Dr. Marina Arnodova of the University of Hertfordshire. Arnodova also admitted that the observed collision led to the formation of a huge shock wave, which she compared to the bang produced by a jet fighter exceeding the speed of sound. When such a wave moves through cold gas pockets in intergalactic center, Stephan's Quintet moves at hypersonic velocity much larger it's than the speed of sound. Arnodova emphasized that the wave is strong enough to tear electrons from atoms, leaving behind a glowing gas. But as the wave moves through the hot gas weakens and the glowing mark becomes much weaker. Instead of causing significant destruction, shockwave compresses hot gas, which is manifested by emissions in the range of radio waves that are recorded by radio telescopes, he explained. Sumaya Deepadasa from the University of Hertfordshire. Arnodova and her team estimate that a shock wave moves through cold gas at speeds more than 25 times the speed the sound. As it moves through the hot gas, it weakens to speed around 4 times the speed of sound. The long-sought background of gravitational waves has been discovered. Researchers working on the NanoGrav, North American Nanohertz Project, Observatory for Gravitational Waves, announced the discovery of a long-sought background gravitational wave, low-frequency space-time vibration. The likely source of a new discovery is a combined signal from multiple couple supermassive black holes. Albert mentioned the gravitational waves for the first time Einstein in the General Theory of Relativity, published in 1916. He had foreseen that the waves emitted by high-speed objects so large masses diverge in space-time, causing it to deform, a bit like waves on the surface of the water. But the first detection of gravitational waves had happened 99 years later. They were registered in September 2015, however, the information was provided only after an in-depth analysis of the data in February 2016. The first detections of gravitational waves were made with the help LIGO and Virgo ground detectors. There were 2 blacks in collision holes, but waves from star collisions were discovered in the following years, the neutron. Astronomers estimate that the events that should cause waves gravitational throughout the space is plentiful and it occurs relatively often. This means that such waves constantly form wrinkles in space-time, and it is they that make up the so-called background of gravitational waves. Now several teams of scientists have announced the discovery low-frequency time wrinkles, so-called nanohertz gravitational waves. The findings were made by tracking the change in the distance between Earth and pulsars in our galactic neighborhood. This showed how the space between the 2 objects is stretched and squeaked by passing wrinkles of space-time. For the last 15 years we've been on a mission to find the high gravitational waves resounding throughout the universe and smuggling our galaxy to curve the space-time in a measurable way. Astrophysicist Stephen Taylor of Vanderbilt University, chair of the team NanoGrav. We're happy to announce that our hard work has paid off and moms of the exciting evidence for this background of gravitational waves, he added. Pulsars are extremely dense neutron stars. They owe its name to the radio beams that emit from their poles, the magnetic. These beams traverse the space in a resemblance way it's a lighthouse. Some rotate hundreds of times per second, others even more often. Because the pulsars spin with such a frenetic speed and regularity, astronomers can use them as a cosmic equivalent of clocks, the atomic. So precise time measurement helps scientists study nature, space-time, and measure the masses of stellar objects. The first detection of gravitational waves came from a collision and the combination of 2 black holes the size of a star. The most likely the source of the latest discovery is a combined signal from many couples significantly larger black holes, millions and even billions more massive than ours, the Sun. The discovered waves are thousands of times stronger and longer than those found in 2015, and their length reaches tens of light years. On the other hand, wrinkles found since 2015, they are only tens or hundreds of kilometers long. It can be said that the Earth vigotes because of the wave's gravity that sweeps our galaxy, says Scott Ransom, astrophysicist from the U.S. National Radio Astronomy Observatory, also involved in the work of NanoGrav. Astronomer pointed out that both he and other teams' researchers are not entirely sure of their findings. Each group saw clues on the expected signature of gravitational waves, but without statistical the certainty of discovery. Scientists talk about discovery when sigma value is 5 or more. Sigma is a measure of statistical certainty. Sigma the 5 means that the probability that this is a random event, fluctuations, disturbance, not real observation, is 1:3500000. Researchers reporting new findings reported detections of levels 3.5 to 4 sigma, which indicates more than 99% certainty that the signal is real. Scientists will now combine their data to see if they can achieve together the threshold of 5 sigma. If this is confirmed, we will have jobs for 20 years. The study of this new background, said Monica Colpi of the University of Technology, Milan by Kaka. This will force the army of astrophysicists to work, he added. 3 teams of scientists have reported similar results based on the analysis of data collected over decades on activity the pulsars. It's the North American group NanoGrav, European Pulsar Timing Array, with the participation of astronomers from India, and Parkes Pulsar Timing Array in Australia. From Railroad 4th Group from China, Chinese Pulsar Timing Array, claims that she found a similar signal based on data only from 3 years, thanks the unique sensitivity of the fast telescope. NanoGrav results have been published in 5 articles, the Astrophysical Journal Letters. The results of the European and Indian teams' research will be published on Astronomy and Astrophysics. A team from Australia sent their research to the Astrophysical Journal Letters and Publications of the Astronomical Society of Australia. In turn, the Chinese published works in Research in Astronomy and Astrophysics. Each group was based on a slightly different data set. NanoGrav monitored the most pulsars. On the other hand, the European-Indian team he analyzed the longest collected data set. An Australian was the only one he watched the pulsars in the southern sky. We are sure of the outcome because we all see the same thing, says Michael Cremay of the Institute of Radio Astronomy. Max Planck. All groups used sensitive radio telescopes for monitoring of milliseconds pulsars. Every time the pulsar rotates, it is around its axis, its radio beam wanders towards the Earth and beyond. This is emissions at regular intervals. Millisequent pulsars rotate fastest, up to a few hundred times a second. We can use them as clocks. The small changes in the time of the coming of signals from the pulsar may mean that the space between the star and the Earth was changed by the passage of the gravitational wave. Andrew Zick of the Australia Telescope National Facility in Sydney. Conclusions drawn from the single pulsar study they would be credible enough. That's why each team monitored dozens of these stars. For this, researchers had to exclude many signals potentially disruptively observed sources, radio interference from terrestrial technology and satellites, dispersal of radio beams from pulsar through gas clouds or minor accidental clouds in its surroundings, changes in rotation of the pulsars themselves. LIGO and Virgo detectors are sensitive to millisecond waves produced by single combinations of black holes or neutron stars. The masses are 10 times the size of the Sunday. Results obtained by synchronization of signals from pulsars represent many instead waves, each with a length of years or decades, overlapping into each other accumulated background noise. Every wave is generated by a supermassive pair black holes somewhere in the universe whose parent galaxies they probably collided and connected. Imagining that the universe is a humming ocean, the stretching and creaching space is unbelievable. Supermassive black holes are cosmic colossus in the hearts of galaxies that feed on gas, and they interfere with the formation of stars. I can't wait for the future where our pulsar observations reveal a complicated map of decaying gravitational waves. It's from pairs of supermassive black holes. We should see the background noise, the universe with specific hotspots, gravitational waves from individual pairs of supermassive black holes lying in galaxies that we can identify, explains Daniel Reardon from Swinburne University, Australia. People have a biological toolkit needed for the production, venom. Geneticists have established a common trait linking people to snatching. Mammals and reptiles have a similar set of genes responsible for activity in tissues that produce saliva and venom. The discovery provides the first direct evidence that venom glands evolved from the early glands, the saliva. People, like mice, are not venomable, but in our genomes are lurking such potential, say Okinawa scientists. Institute of Science and Technology Graduate University, OIST, an Australian national university their research shows that people have a biological set the tools needed to produce venom. Scientists have shared their findings in the journal PNAS. Yads are a cocktail of proteins that animals use to immobilize and the killing of the victims, as well as for self-defense. It's interesting that venom occurs in so many different animals: jellyfish, spiders, scorpions, serfs, and even some mammals, says lead author Agnieszka Barua from OIST. Evolution has made ways of delivering venom significantly they are different. However, a system that uses the mouth, from where the venom is injected by the bite, is one of the most common, he emphasizes the scientist. Recent research on the sneeze, commonly known predators using venom, reveal genetic basis of origin this mechanism. So far, scientists have focused on genes they are responsible for the production of proteins that make up the toxic mixture. However, much toxins that can be found in animal venom appeared after the establishment of the venom system itself. We wanted to look at the genome, which were present before the formation of venom, the genome that made it possible venomer systems, Barua says. Scientists used Taiwanese venom glands for research. Habu snake, Trimers urus flavovirides, found in Asia. The team he was looking for genes that interact with those responsible for composition the venom. The researchers identified about 3,000 similar ones, cooperating genes. They found that they play an important role in protecting cells from the effects of large protein production. The genes were also key in modification of protein composition. For protein to form, long chains of amino acids must couple as a specific way, otherwise they will not function properly. Miscoolate proteins can accumulate and damage the cells. That is why the role of cooperating genes seems so important. The vents are complex mixtures of proteins. To ensure yourself the possibility of their efficient production requires a solid system, which he will ensure that they are properly assembled, Barua explains. The researchers then looked at the genomes of other creatures from a whole kingdom of animals, including mammals like dogs, chimpanzees, and humans. They have their own versions of similar genes. When the syndrome looked at the tissues of the salivary glands mammals, he found that genes had a similar pattern of activity to the one that could be seen the venom glands of the venomous of the snasks. Scientists believe that the glands swin in mammals and venom glands in venoms divide the ancient core of DNA, the two lines separated. Many scientists intuitively felt that this could be the case. However, now we have the first true proof of the theory that the venom glands they evolved from the early salivary glands, Barua says. Visible ease with which the function of the salivary glands can be used to make venom is surprising. The scientists are starting look at other mammals in a new, disturbing light. Perhaps in a few hundred years the mice will evolve in such a way as to produce a toxic venom. Some of the research from previous years, they seem to confirm the validity of similar concerns. And although it is very unlikely, if there have ever been adequate ecological conditions, people could also to be able to. It definitely gives a completely new meaning to the expression toxic person, Barua jokes. 168